Hi guys, welcome for who is starting in our products of our products from AutoCAD. For who has already has our products too. I'm very happy. The people who doesn't know our products and is learning and having the first contact, I believe that it will be a very interesting course. I wanted to bring one material that was compiled last year for the team of Infra SA from Brasilia during the one training that they work properly with this segment of the railway. I believe that will be one very relevant topic, important for who has the curiosity and went to explore the software or the back of the software for this segment of infrastructure. I believe that we will be the potential, the very big potential in this training. Inside that was prepared, had been prepared for you. So again, welcome for this course, the conceptual model of railway. I hope that you enjoy and like too. All right. So starting from the chapter 1, I will do a general overview before to talk about this chapter that you'll be watch in terms of the content for this training. How do you make for to download the files to better to have the better joining? You explain. So you take the original files, from then or from it, you do the style process for each chapter. The final of each chapter, you do the comparison for done in each step. So starting from this introduction, what happens? We would receive our database from 2D in AutoCAD, for example, polyline, line, and other elements, and you need to convert this owner or own elements, they represent the natives from Civil 3D, to extract the better information as possible. Anyway, in terms of the development, the axis, the calculate of super elevation. In that case, when we have a horizontal alignment, in terms of the adjust the length of the vertical curves, the key factor, and etc. So you know that with the data from CAD, you don't the same smart and the same dynamic when we are working with data from Civil 3D. So if you want to change one station, for example, if you want to input, to calculate a new station, to adjust one PVI, adjust one PI. Anyway, all of the risks from this data will be affected. And the software will recalculate all of these elements for us. So through this manner, we will to need this transformation. You need to do this transformation. The CADs from the data from CAD to Civil 3D. So the subchapter 1-1, you'll be the relative or about for treatment of survey database. You will take contour lines. You have contour lines, the final products of aerophotogrammetry, and you transform this in a one-chain surface. It's just the same goal of example that I wanted to bring about the horizontal alignment, vertical alignment, and you transform the polylines, the dump polylines. How do I say? For the intelligent elements into the software. Okay. So for this, to do all this process, we need to pass through. For this process, we will do some questions about the additions for delimitation of surface. entering in the axis stud or the horizontal alignment stud, we will take to develop one drawing open one drawing open the previous drawing done. As I mentioned before, like having the polylines, the lines and the arcs from the CAD that we will transform this in a alignment from Civil 3D. So we will do this element from CAD converting to Civil 3D. So we don't convert in this case as you saw several cases before. Because other eyes will take many vertices there, and you don't interesting to us. So we will take one baseline that we need to follow. Example, length from tangent or tangent length, tangent or spiral tangent, radius of curve, etc. And there you input one starting station for this element. You edit also this geometry anyway to adjust perfectly to let coincident with the original 2D object and to follow all the premise as possible. I will bring one example from individual AMV, aparelho de mudança viária. For this axis, for this basic project, we will take one specific case that makes, how do I say, the change of direction, no? About the mudança viária. That it's very usual and real in many projects of rail. And I will bring one example that we will work with reverse curve to connect the same alignment. And I will bring also some case that you can to apply the calculate of super elevation the adequate way with custom or specific subassemblies, no? And specific assemblies. It's better says with subassemblies that accepts this kind of calculate and do explanation of critical points and explanation about critical points inside the alignment. So we will see it's a very similar that we do for the roadway. It's the follows more or less the same criteria and the same products. But just for this case, we will take a one difference in terms of in the transversal inclination, just to be the very sensible. You don't have the centripetal force action in the when you have in the vehicles for one roadway. So it's changed a little bit. About the methodology and criteria. So now about the vertical geometry, we will create profiles inside it. So how we are usual to do in the other case, we need to produce one profile directly from the topography database, no? So creating a profile view, we create a profile from the existing ground, and you see that you'll be matched perfectly in a 100% that we already have inside the CAD. So just remember that the goal here is to transform the elements to Civil 3D. So for this reason, we need this objective called profile. Okay, we need to do one new object, for example, one new profile inside the vertical alignment, for the vertical alignment, better saying from the CAD. So we have some ways to do this. The better way, or the fast way, just create the profile following the critical vertical points, no, or notable points. I don't know how the foreign guys say this, but in Brazil we call notable points. You match, or you to let equal the key factor and the length of the vertical curve from this object of the CAD. For the chapter 2, as we are as usual, we work with external reference for all necessary elements that are in our project. For example, the profile. When I say profile, the profile from the existing ground, the profile from the layout, the profile layout. Basically, the alignment profile, profiles, the surface, obviously, without forget the surface. When we can to gain the maximum desempeño of our software machine performance. And so any change that it's done there, for example, for one the topographic file, it will be affecting our project file. So it's that's our intention, to separate the drawings. No, so you take the own file for the topography and another for the technique study and another relative of this chapter. Establish with the abutment, finding the body of the railway, the platform. In this case, you create the topsoil of surface with base topsoil, as I mentioned before. And now we will entering about the documentation and calculate. That's a fourth phase, no, related to the extraction of quantitatives for us, and to define there what you enter or not inside our volumetry, so or volume. So are you take one specific trench? No, that trench no. Specific não sei, that you need to remove from the total quantitative. That's a trench. You take it to consider as a third category. So you will see that include the subassemblies, bringing a little bit in the previous. You do subassemblies with slopes and more strict, considering the geotechnic established, containing there the soil, in the case the rock. No, just a hypothetical. So just a hypothetical case. So you create also the corridors from the slopes, right? As I said before. So choose corridors from slopes. You be in fact the regions, right? So you take regions also about the slopes to incorporate the same only corridor of a railway, and you take another corridor just for the slopes to define the triangulation, just to avoid the mixed with one and another. No. So you need to do some adjusts inside the banks considering the diff of ballast, sleeper, and so on to let compatible with the slopes there, respecting the height of those taludes, those slopes. So in this step, you will do many process in terms of production of labels to show the tangent length with one table showing the deflection, the coordinates, the central angle, and the circular curve. So that's the idea here is to be the very complete material, including the service notes. You take information very adequate there inside the section views, adapt there, and I import our file to contain the correct organization of data about the offset and level, direct from the template. So the plant production documentation is you use one separate sheet, one customized sheet in our template of view frames. So you'll be very interesting. So now we are entering the chapter 5 about the transversal drainage. You do the new thing inside this training. You do dimensioning with the based on the critical diff, using the level of the water or the rain montage in the tail water. We will enter with hydraulic and hydrology methods to do some adjusts and edits. I will show some details of softwares too that sometimes avoid to calculate automatically inside our customized element. You need to use one native element from pipe network to do this change. Those changes. We will bring several examples about the customized, and using part builder, you'll be one thing very complete. And I will obtain the surface about curvas mistas from the previous studies to analyze the flow of or the path of rain. And here you enter inside the finalizing modeling, finishing modeling. So you have the group of items predefined that will be combined with codes from the two subassemblies, customized subassemblies, mainly the code links, code shapes, and the names of the subassemblies, the main names of the subassemblies that you need to incorporate of this dialog box. We will do some additions also using the extension file JSON, the programming language open programming language to work with this method. We can adjust this outside of the from the software to configure all of these things. It's interesting that to have one standard of styles to import in each moment that we start one new project. So for example, I want to turn on one specific style, for example, coverage with a specific color in InfraWorks. In this manner, I can pre-configure this before to prepare. The same thing for the ballast and the rocks to insert a JPEG image and so on. So there we can customize automatically many things and turn on the first only one moment. You see, we will to let our model very rich with several data such as pipes, and trees and rivers. And you use the pipe studied there in Civil 3D to import inside the InfraWorks, such as one mark, to obtain the information to create our curve culvert inside the InfraWorks using this information with walls, combining with inclination that we studied inside the Civil 3D. We will create a bridge and etc. We will do many things there inside the InfraWorks based on one online map to input more elements there, such as vehicles off rail, locomotives. And here you enter inside the subchapter 6.2. You come back to the Civil 3D to import the database about related to the superstructure, including piers, foundations, abutment decks, and etc. So with all of the thing, we will carry into our final file inside Civil 3D to project there then inside the profile used in our study. The same profile that you studied before, okay? So that's it. So you see now in the next chapter that's where I explain how things are organized, the files, where we can download them or download it. Thanks.